Hi everybody, it's Mrs. Pound and we're back to chapter 1.4 about the structure of the earth. We're going to finish the chapter today. So far we have talked about the core and the mantle, so now we need to talk about the crust. So section 1.43 is about the crust. So our objectives today are to describe the features of the Earth's crust and to compare and contrast the continental crust with the oceanic crust. So the crust is the thin, hard outer layer of the Earth. A lot like this apple here, it's extremely thin. The peel on an apple is the thinnest part of the apple, the outside, and so is the Earth's crust. And remember from the models we made in class that our Play-Doh wouldn't even spread thin enough around the outside. That's just how thin the crust is. This is the only layer that has been directly observed. Remember, we have not even made it drilling through the crust. It's Earth's thinnest layer. We've talked about that. It ranges in depth from 6 to 40 kilometers. And it has a cool outer temperature, which is good for us. It's at the bottom of the crust, it's quite warm because it's next to the mantle, but at the top of the crust it's very good because otherwise we would literally cook if we did not have this outer crust. And let's go ahead and let's take a look at our reference tables for a minute. Okay, so we're back to our reference tables. We've talked about the inner core, the outer core, the stiffer mantle, the asthenosphere, okay, the moho, which is the boundary between the mantle and the crust, all right? And so now we're just talking about this very thinnest layer on the outside here, right here. And if we go down, 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 down to temperature, it's right here, and it's right on the zero. So quite a bit cooler from the inner core and even quite a bit cooler from the asthenosphere. Okay, so it cools quite a bit. And even from, from the top of the asthenosphere. At the top of the asthenosphere, it's about 1,000 degrees. And by the time we get to the top, it's down to zero. So a sharp cooling curve there. Otherwise, we would not be able to survive. So those are some important features of the crust in general. Now let's take a look at the continental crust versus the oceanic crust. So the continental crust is the crust on which the continents rest. And you would think they'd probably be pretty similar, but they're not. They're quite different. The continental crust is mostly granite, which has other types of minerals and rocks in it. The continental crust is mostly granite, but it also has other types of minerals and rocks in it, as we can see because we have looked at many examples of rocks in lab previous to this chapter. But remember, granite tends to be lighter in color. It tends to be less dense. It also has regions classified by composition and formation, such as shields, which are vast regions of where igneous rock has been laid down. Fold belts, where we see mountain formation, okay? And sedimentary basins, which are low areas where sedimentary rock has formed due to oceans and different other types of water. Or bodies of water. So it's very diverse, and we're going to talk about each of these formations in other chapters, but I think it just shows God's creativity. He did not make everything the same. Our God is so creative. There's also the oceanic crust, which is very different from the continental crust. This is the crust beneath the oceans. Now, as opposed to being made of granite, the oceanic crust tends to be made of basalt. That is the primary rock. It has the same composition in all its layers. And it is composed of layers of cooled lava and dikes made of basalt and gabbros. Uh, Dikes are, if you look in this picture, see the different colors of rock here? This basalt pushed up through, and it looks like a wall. A dike is basically a wall, and it looks like a wall pushed up through this rock. So that is a dike. Uh, and these vary according to the movement of lava in different layers. There's pillow lava, which you see in the background here. It's kind of bubbly looking. There are sheet flows that can happen. This is where it covers a large area like a sheet. Kind of interesting that there's kind of bed covering type terminology here that they use. And sheeted dikes. These are the dikes, these are pillars that kind of go up through. There's igneous activity, volcanic activity, and the igneous rock goes up through cracks, and that's what forms the dikes. So that's pretty much it for the crust. We have described the features of the Earth's crust, and we have compared and contrasted the continental crust with the oceanic crust. So don't forget your 5 questions, and we are done with the chapter. So start studying Quizlet and getting prepared for the test.